Today we continue our study on functions by talking about operations on functions. We're going to start with sums and differences of functions. So, if you have two functions f and g, the sum is a new function, we can call it h, defined by this rule, where h of x would be equal to f of x plus g of x. Now the one that's over here on the right, this is just another way to write it. It's the more common way of writing it, where you have f plus g in parentheses of x. It's just a shorter way of writing it so that you don't have to write f of x plus g of x. You know that both f and g are defined in terms of x. Similarly, if you have two functions f and g and you're trying to find the difference, then you can define it as a new function h, where you are subtracting f of x minus g of x, or another way to write it is with f minus g in parentheses of x. So again, that's just a shorter way of writing it because you know that both f and g are defined in terms of x. Let's do an example. We have f of x equals 3x squared plus x, g of x is equal to 4x minus 2. Find f plus g of x. So again, f plus g of x really just means f of x plus g of x. And so we'll go ahead and add 3x squared plus x plus 4x minus 2. Combine any like terms that you see there, and we have 3x squared plus 5x minus 2, and that is our answer. Now let's look at an example where we have the difference of two functions. So we'll still use the same two functions for f and g, but this time we're finding f minus g of x. Again, we can rewrite this if it's helpful to write it as f of x minus g of x. With the difference of functions, you just want to be sure that when you are subtracting g of x, you are subtracting the whole function. So I would suggest just writing each function in parentheses. So I'm going to write parentheses 3x squared plus x minus parentheses 4x minus 2. Now that minus that's in front of the 4x minus 2, I'll know to go ahead and distribute that. So this becomes minus 4x plus 2. Now we can combine like terms. So x minus 4x is minus 3x. So we have 3x squared minus 3x plus 2. And that's our answer. All right, so we've talked about the sum and the difference of functions. Now we're going to talk about the products and quotients of functions. So if you have two functions f and g, the product is a new function h defined by this rule where you multiply f of x times g of x, or another way to write it is f times g in parentheses of x. Similarly with quotients, if f and g are functions, the quotient is a new function h defined by the rule f of x over g of x, or again, another way to write this is f over g of x, just so you don't have to write the x so many times. All right, look at example 3. F of x equals 3x, g of x equals x squared minus 1. Write the rule for f times g of x. So this just is the product of f of x and g of x. So I'm going to multiply this. Now notice I'm going to write this in parentheses, so 3x times x squared minus 1. That way I'll remember to distribute the 3x. So this is equal to 3x cubed minus 3x, and that is our answer. All right, for the next one, we have a quotient. We're still working with the same values for f and g. So f over g of x is the same as f of x divided by g of x. So all we have to do is put 3x in the numerator, x squared minus 1 in the denominator, and you're all done. All right, the next type of operations on functions that we're going to go over is what we call composition of functions. So say you have two functions f and g, then the composite function of f and g is going to be this. So we use this little circle here to denote composition, and what it means is that you are going to put the function that's after the little circle inside the function that's before the little circle. So that means in this case, you would plug f into your function g. You can also think of it as whichever function is closer to the x is the one that gets plugged into the other function. All right, so look at example 5. If f of x equals 4x squared plus 1 and g of x equals x plus 2, find. Okay, so this first one we have g composed with f of 2. So you always start with what's on the rightmost part and you plug it into f. Whatever you get from that, you're going to plug into g. So let's first start by finding f of 2, the part on the inside. So f of 2, we simply plug 2 into our function f. So we have 4 times 2 squared plus 1. So that's 4 times 4, which is 16, plus 1, which is 17. All right, so now we have our result there. Now I'm going to plug the 17 in for f of 2. So this is going to be g of 17 now. And now I plug 17 into the function g. So this is 17 plus 2, which is 19. So my answer is 19. So you always start by plugging into the function that's closest to the x first, and then your result from that goes into the next function. Let's do another one. F composed with g of negative 1. So we are going to start by finding g of negative 1. Plug negative 1 in to our function g. We have negative 1 plus 2, which is equal to 1. Now I'm going to replace the g of negative 1 with 1. So now I find f of 1. So I plug 1 into my function f. So that's going to be 4 times 1 squared plus 1, which is equal to 5. So 5 is my answer there. Now what if you're not given an actual number to work with? Let's say in the next ones we have g composed with f of x. So in this case, we are simply going to take f of x and we are going to plug that into our function g. So f of x is equal to 4x squared plus 1. So I'm going to plug that entire thing in wherever I see x in our function g. So this will be 4x squared plus 1 plus 2, which equals 4x squared plus 3. Now, what if we did it the other way, f composed with g of x? So this is the same as plugging g of x into our function f. So g of x is equal to x plus 2. So I'm going to take x plus 2, and I'm going to plug that into my function f anywhere I see x. So this will be 4 parentheses x plus 2 squared plus 1. So in this case, to simplify this, I'm going to have to multiply that x plus 2 squared out. So this is going to be 4 parentheses x squared plus 4x plus 4 plus 1. And then I can distribute that 4. So this will be 4x squared plus 16x plus 16 plus 1. And then I can combine like terms and we'll end up with 4x squared plus 16x plus 17. Now let's talk about the domain of composed functions. So if you have g composed with f, the domain of g composed with f is going to be the set of all real numbers x such that x is in the domain of f and f of x is in the domain of g. So because we're always talking about the values of x, the input values that can go into each function, with a composed function, you have two different inputs. So first you're inputting x into f, and second you're plugging in f of x into g. So we need to find the domain of both in order to find the domain of the composed function. Take a look at example 6. If f of x equals the square root of x and g of x equals x squared minus 5, find g composed with f and the domain of the composite function. Okay, so let's start by finding g composed with f. You are plugging in your function f into g. So we're taking that square root of x and we're plugging it in to x in the g function. So this is g of the square root of x, which is the square root of x squared minus 5. So that's equal to x minus 5. Now, as to the domain, we first look at the inside function, which is f. The domain of the function f would be what? Well, for the function f, we have a square root in there, and we know that what's under the square root must be greater than or equal to 0. So the domain of f is x greater than or equal to 0. Now for our function g of x, what values of x can you plug into x squared minus 5? Well, x can be all real numbers. There's no square root, there's no denominator. So now, to figure out the domain of the composite function, g composed with f, you have to combine both of those domains and write the domain that is the most restrictive. So in this case, the domain is going to be x greater than or equal to 0. So although our solution at the end was simply x minus 5, and it looks like the domain is all real numbers, it's actually not all real numbers because this is a composition of functions, and if x were less than 0, we wouldn't be able to find a value for y when we first plug it into the function f. Now let's look at how we can go about decomposing a function. So say you have a function h of x equals the square root of 3x squared plus 1. Write h as a composition of functions in two different ways. So there are actually many different ways you can go about decomposing a function. So here it's just asking you to show two different ways to do it. So for example, what you could do is you can take what's inside the square root and make that our function f, our inner function, and then make g of x the outer function, which would just be the square root part. So you can check to see if this works. So g composed with f means I plug in f of x, which is the 3x squared plus 1, into g of x, which is the square root, which gives us the square root of 3x squared plus 1, which is that original function h of x. So that's one way to do it. Another way to do it is to make the inner function just 3x squared, and then make the outer function the square root of x plus 1. So I'm going to use different letters so we aren't going to confuse this with our previous decomposition method. So let's say we let k of x equal 3x squared and j of x equal the square root of x plus 1. So now, if we did j composed with k, we're plugging in our function k, which is 3x squared, into our function j, which is the square root of x plus 1. So plugging in 3x squared where I see x, I end up with the square root of 3x squared plus 1, which is my original function h of x. So again, with decomposition, there are many ways you can go about this, but you just want to make sure when you do actually compose the two functions together, you end up with that original function.